Today my topic is Thevenin's theorem. My topic is Thevenin's theorem. To apply Thevenin's theorem in a particular numerical problem, there are three steps that you need to follow. First one is deactivate all the sources. It may be voltage source or current source. To deactivate voltage source, we have to replace the voltage source with their internal resistance. For the case of ideal voltage source, it is 0, so we have to make it short. And to deactivate current source, we have to open the current source circuit as the internal resistance of the current source is infinite. Now this is a typical Thevenin equivalent circuit. Here we can see that Thevenin voltage and Thevenin resistance, they are connected in series, and across the load terminal AB we have to connect the load. Now this is a typical example. Here the load that has been connected at terminal A and B with the load resistance value is 2 ohm. Now we have to apply Thevenin theorem with for this circuit, and we have to find out the voltage across AB, that is Vx. Now first step is to find the V Thevenin, that is across AB. Here from this circuit, first we have to remove the load, and then you have to remove the load, and then you have to find out the voltage across A and B. Now to find out the voltage across AB, that is Thevenin voltage, what you have to do, you have to find the current through this circuit, and as this A and B terminal is opened, so only one current that will flow through this circuit in this loop, in this left hand side loop, because right hand there will be no current flow to the right hand side loop as it is open circuited. So we need to find out the current through this left hand side loop. The current value will be 30 divided by 6 plus 12, as 12 and 6 ohm are connected in series. So 30 divided by 6 plus 12, that is 30 divided by, basically it is 18. And the potential across AB, that will be 30 divided by 6 plus 12 into 6, because this resistance is 6 ohm. So it has been calculated 10 ohm. So this is basically your Thevenin voltage. And for Thevenin resistance, that is RTH, what you have to do, you have to replace all the sources. Here only one source is present, that is 30 volt voltage source. So we have to replace this voltage source with their internal resistance. So as the voltage internal resistance of the voltage source is 0, so we have to make it short, and we have to find out the Thevenin resistance from the terminal AB. So from this circuit you can see this 12 ohm and 6 ohm are connected in parallel, and the combination that is connected in series across the terminal A and B. So that's why 12 and 6 are in parallel, plus and the combination that is connected in series with this 4. So we have to find out the Thevenin resistance, that is 8 ohm. Now this is the Thevenin voltage 10 volt that we have already calculated. This is Thevenin resistance 8 ohm, and 2 ohm is the load resistance. So from this simple circuit we can find the voltage across Vx, that is 10 into 2 by divided by 2 plus 8, that is 2 volt. So in this way we can find the voltage by using this Thevenin's theorem. Thank you.